Hey everyone, it's Drew back. Today we're going to be designing a West Coast drive. Pretty simple, pretty straightforward. I'm not going to go super in depth, but for the most part, this should get you from start to finish with everything you need. So my West Coast drive is going to be 28 by 28 inches. Why? Because I want it to be. So to start off, we're going to make the first drive rail. So that's, I call it side rail, drive rail. It's the 2x1 tube with the motors, gearboxes, etc., wheels on it. So I could go make a new part. I go to I click extrude, boss base, go to the right plane. Why the right plane? I don't know. I've just standardized on it. It's good to standardize on something. So I'm going to click R because that's my hotkey for center point rectangle. Make that off the origin. I'm going to mention the top to 1 inch and the side to 2 inch. I'm using D as my hotkey for dimension because I'm using 2x1 tube. Now the thickness of this tube, I'm going to make it a walled tube, not a solid object, by using the offset entities tool. I click O to get that, and once I click it, that yellow line represents where the offset is going to go, offset inside or offset outside. It selects the whole rectangle because I have this select chain thing selected. I'm going to go reverse to put it on the inside. I'm going to do 0.125. Whoops, my numlock is off. There it goes. So 0.125, an 1/8 inch wall tubing, 2x1 is a pretty standard size. Now I know I said it's going to be 28 by 28 inches, but that's going to be the outside frame perimeter. So I'll go in depth into more later why this is the case. But I'm going to make this 26 inches long. Just 26, nice and easy. Extrude that, and there's my first tube. Now the first thing I'm going to do on it real quick, make our hole pattern. I start by getting a construction line, which I get by pressing J. That's my hotkey for it. Or you can go to line and go center line, construction line, center line, same thing. I'm going to select both of these by holding Shift and clicking on both, or you can hold Control and click on both. That works too. It'll bring up my relations tab. I'm going to set my relations to equals. What that means is these two lines are, by definition, equal. The reason I go right from the center here out to the end here is from the center of this 1 inch tube is 1/2 inch. So if that defines this length as 1/2 inch, it means the width's also 1/2 inch. So I have a point that's exactly centered on the tube that's a 1/2 inch away, which is perfect for my 1/2 inch hole pattern. I'll dimension the hole is 0.196, which is a 1032 through hole, close size. I'm going to extrude cut with my Control E and put through all. So I'm going to get that hole in there. And then I'm going to pattern this hole all the way down the tube. The way I'm going to do that is I'm going to select this side right here, just to have some direction for it to follow. And I have this the option on up to reference, not spacing instances. And the reason I'm going to do that, I'm going to select this little reference blocks and click the end of the tube. That's going to be my reference. I want my offset distance to be roughly 0.1 inches. That just means how far offset from my reference plane do I want my pattern to stop. And the reason I have this is just any greater than 0 value, and I'll show you why in just a moment. I'm going to set my spacing to be 0.5, and then I don't need a direction 2. I just care about this one. I'm going to go to features and faces, select the feature, and select my hole. And that's going to see those yellow dots. Those are my holes. And it's going to stop right exactly a 1/2 inch from the edge because my total length is 26 inches, which means it's evenly divisible by 0.5. If I don't have that 0.1 there, if I don't have that there, it's going to try putting a hole sometimes at the very end. Why did it not go down? Okay, can I type it in a 0? It's not letting me do the buttons. There it goes. So it's going to try putting a hole at the very end because it's evenly divisible. I don't want that. So I just do the little tick mark up. It's pretty easy. And that's how I make my hole pattern on the tube. I'm not going to do a side hole pattern, but I'm just going to jump right into figuring out where my wheels are going to go. So let's say I'm going to have a 6-wheel drive. I'm just making this up as I go with 1/8 inch center drop. So I'm going to do a midpoint line. So the way I did that is I press K on my keyboard, or you go over to line, midpoint line. I go to the origin, I just drag it out any point, and a midpoint line goes off your original click point out in both directions. So I'm going to use this for my wheel offset. I'm going to change it to construction, just reiterate how I did that. I just click on it and click on this construction geometry. When it's shaded in, it is now construction, so it won't affect my final part. Construction geometry doesn't have any effect on what you actually use in features. So I'll make that about 1/8 of an inch. And because it's a 6-wheel drive, I'm going to go out like this. With another midpoint line right there. Sorry for the short little stutters. Drag that out a little bit. The very bottom of here, I'm just going to sketch out my wheels real quick. Most of the time I don't do this because I have a whole layout sketch determining where everything goes, but I'm not doing that for the sake of time. So I'm going to make all those wheels equal just by holding Shift and Control and selecting them and setting them equal. And then I'm going to select all of them and say construction geometry because they're just for me to look at. I'm using 4-inch wheels. And, just because I want this to be roughly 2.5 inches from the edge. So this gives me my positions pretty perfectly. I'm going to have my gearbox in the middle. So I'm using a West Coast Drive gearbox from West Coast Products. And that's going to use a bearing block style West Coast Drive. So pretty standard, something that you buy. When we're using a bearing block, you want to have your bearing block hole for your gearbox bearing block to be about 1.5 inches. Normally you add a little bit of extra for tolerancing, but for design purposes, I'm just putting this in here. We'll have another video on tolerancing. I'll do another midpoint line because the gearbox that we're attaching with has 4 inline holes that you mount to. The inner 2 are 1.875 inches apart, so I'm just going to define that midpoint line by 1.875 inches. And then the outer 2 are 4.5 inches apart, and that's just a standard for the gearboxes. They're all pretty swap outable. It's nice. So I'm just going to put a hole, just little circles in each one. I'm going to set these all equal to each other. And these are going to be 0.196 as well. All number 10 clearance holes. Alright, as for our side bearing blocks, the side bearing blocks are slotted. So it's how you tension the chains. You have a slotted bearing block, so it slides left and right. So in order to start with the slot, we're going to make a center point rectangle on that spot. The slot is 1.375 high and 1.875 long. So of course in actual practice you'd add a bit just for tolerancing, make it so it's not a perfect press fit, but for the intents and purposes of this practice we're just going to do it this way. So now the slot for the actual slot for the bolts for the bearing block, I'm going to use a center point straight slot. I don't have a hotkey for this, so I just go select it. I gotta start from the center, and it goes evenly in both directions, and I just bring it out a little outside. I want to define my radius as 0.196 over 2, because it's a 0.196 diameter, but because we define the radius of a slot, slots are defined by radii, or radii, however you say it. So that looks pretty nice there. And then I want the distance between the center point of my slot and the wall of the slot to be about 3/16. So I want a total of about 3/8 of travel left and right, so 3/16 on either side. And right before I finish my slot, make a little hole in line, and this is where my tensioner is going to go. So my tensioner is going to bolt through. And the distance between the center of the block and the tensioner location is 1.875 inches. All very clean numbers. And that's it for this side. What we're going to end up doing is I'm just going to make a vertical construction line, and we're making that center with a tube. We're just going to mirror all this to the other side. And the way we do that, we click on mirror entities up here. Select all that, just top left to bottom right. Then we click on the mirror about line, and voila, looks pretty clean. To cut this out, I'll just select the different parts of my slot. Select the holes. Now, because we have so many different contours that are intersecting, we have to select the actual contours. If you put in a little bit extra time and work and make everything singular contours that don't intersect, then it should automatically select everything. So I'll get these in. And I know the 26 inches is technically enough, but it's good practice to just say through all. So here's my first tube. In order to technically finish it off and make it more manufacturable with my resources, I'm going to fillet these inside corners to 1/4 inch. Normally, I should probably talk about fillets. To get to fillets, press F. Fillets turn the inside of corners into radius, makes it rounded. So we will put that into the corners manually. There's a tool called Fillet Expert I'll talk about later on, and there's a reason why it doesn't exactly fit in really nicely here. We fillet things for several reasons. My favorite reason is it looks nice, but it's a lot more than that. It makes an area stronger, especially the cutout area, because if a load is concentrated at a corner, it's concentrated at a singular point. Whereas if you have a radius in contact, it's spread out over the radius the load is. So that's pretty nice. And then it makes it much more manufacturable with our resources. So 299 has a CNC router we make all of our tube on and all of our plates on. And when you cut things on a router or a mill, you are cutting things to the dimensions of the tool that you're using. So whatever kind of end mill that you have, end mills are typically all round. So the diameter of your end mill is the diameter of your fillets, or radius by technicality. So we're going to do 1/4 inch here. The reason we do 1/4 inch is because that's to match the 1/4 inch radius on the bearing block. And we will click enter, and that's our first tube entirely done. Nothing more that we really need to do to it, so we'll save. Oops, let me navigate. Here we go. So I'm just going to do this. I have my own naming convention for this. If you're doing your own user project, have your own naming convention that follows our team naming conventions, and look that up in the frequently asked questions doc. So I'm going to make another part right now, and this is going to be the front and back rails. These are going to be much simpler. Start with the same center point rectangle, 2 by 1 inches. Now when I offset this, I'm going to use 1/16 of an inch instead of 1/8 inch wall tubing. The reason is I don't need the strength of the 1/8 inch wall tubing for the front and back. I'm going to make it 28 inches. I need 1/8 inch wall tubing on the drive side so that the motors and gearboxes and wheels and all the load that's required to move the robot is taken nicely and doesn't break the tube. The front and back, sometimes you should make it 1/8, sometimes not. It's really a case by case basis. And you get a feel for that the more you make robots. So I'm doing our standard hole pattern here, and then linear pattern. Up to reference, I'll select a reference from the side. Increase that to 0.1. Spacing is 0.5. And that's it. That's it for this part, really. This is really standard stuff. When you get into actual fuller robots, you'll have more details to add. But for the most part, we've gotten the 2 parts that we need to actually make. So what we're going to do now is go to New, 299 Assembly. And we're going to start making this. So we'll select our first part in the Open Documents. 01 is the drive tube. So just click check mark. Clicking check mark after selecting something puts it fixed at the origin. So the origin, you can see, is right there in the center. But we don't want that. We want the origin to be at the center of the drivetrain. So that little F next to the part number or the part name means it's fixed. Just fixed in space, it won't move. In order to change that, I want to right click on this and go down to float. That's going to mean I can drag it around. but we want to make sure that our assembly is fixed in some way, shape, or form, or at least defined. We don't want it to be free moving. But for now, we'll get to it. We'll get to that later. What we want to do is we want to define where we want our first tube to be. So I'm going to say that this is one side of the robot. So I want the center of this tube to be with the center plane of the assembly. So that we select that right plane and then click a little arrow here to get all the features of the tube. And we can see that that right plane is somewhat close enough to the right plane of the assembly. I'm going to hold Control and click that and use the coincident mate to get them together. Coincident just means that they're on top of each other in the same position, the same plane, the same spot. So now I can't move this forward and back, just up, down, left, right. If it looks like I'm moving it forward and back, it's actually moving in the X direction when I've already secured it in the Z direction. So now we're going to go to the top plane. Go to top plane there. Do the same thing. So now you can see it's a little more rigid. It can move exactly in this direction, but not in the other one. So what I'm going to do, I'm going to find that front plane. I'm going to select it. I'm going to mirror this part across. So I'm going to go under linear component pattern to mirror components. I already have that plane selected. I'm just going to select this part and say check mark, and there's one mirrored across the exact center. So if I move it, you can see it moves with it. Now I'm going to bring in my O2 part. I'm just going to drag this out to wherever. I'm not just going to click check. And if I use my right mouse button, I can move it around. What I want to do is mate it. So I'm going to click mate. Mate is how you connect parts in assemblies. So I'm going to click on the top face of each one to say that the top faces are coincident. And again, coincident means that they're the same level, the same position, the same height. Now, if you see, it's still at some kind of a weird angle. So I'm going to click on this face and put it over here. So it says where it's contacting. Now, what I'm going to do to make this a little bit simpler, to turn two mates into one, or sorry, three mates into two, I'm going to select this tube, go to its right side, and select its right plane, which is the very center. Now I want to make its right plane parallel with the tubes down the very center, which for the assembly is the front plane. So I'm going to make the right plane of this tube to the front plane of the assembly. So you can see how now it lines up nicely with the tubes. And what I'm going to do from here is I want the spacing for my wheels to be 1.5 inches. So I'm going to do what's called a quick mate. It's the exact same thing as a normal mate. I just select one face, I hold Control or Shift, I select another face, exactly what I did at the beginning, and it gives me this little toolbar up here. So I'm going to use a distance mate. I'm going to say 1.5 inches. And you can see that that's defined the other side as well. If you look, I can't move this. It says the selected component is fully defined. That's what we want. So now I'm going to mirror this back piece to the front. So I'm going to go to the right plane, mirror components, select that and say check. And the frame of my drivetrain for the most part is, together. There's some obvious parts that are missing. For example, there's nothing actually holding them together in real life. They're being held together by magic SolidWorks glue, which doesn't exist in real life. SolidWorks says that we've said that they're coincident and that it's all defined. But in real life, if I put the four tubes next to each other, there's nothing to say that they're going to stay there. So we'll get to that later, but for now, let's see. I'm going to open up our library, go down to WCD, which is West Coast Drive, and we get this side bearing block right here. All right. Now if you look at the bearing block, there's a thicker plate and a thinner plate. What we're going to do is we're going to get the face of the thicker plate, and using our quick mate, we're going to make that, whoops, it is. We're going to make that coincident with the plate of the tube, but because I wasn't holding Control or Shift, and I clipped, I lost my selection there. So I'm going to go do that again. That looks good. Now I'm going to do what's called a width mate. I'll show you how to do it once in the actual mate area, and then I'll show you how to do it again with a quick mate. So if I go click on mate, this is standard mates. If we go down to advanced mates, we have this width, and width is really nice. You basically select between 3 or 4 different selections. You can put something right in the middle of something else. So if I want to put this block in the middle of this slot, I'll just click left to right, 2 sides, and then I'll select left to right, 2 sides, and it centers the block. And we can do this to get it centered in the entirety of the tube. The entirety is not the right word. In the height. So I'm going to do this with quick mates. I'm just going to select the top, hold Control, select the bottom, hold Control, select the top, hold Control, select the bottom, and the only option here is a width. So I'm going to put that in, and that's pretty solidly there. Now, this needs some bolts to go through to hold the bearing block together. If I click on one face, I hold Control and click on another face and click M, the measure tool. It says I need, alright, that's in metric. I don't know why that's in metric. There you go. I need 1.31 inches, roughly. So the closest I'll get with that is 1.375. So I will use a 1 3/8 flathead cap screw 1032. So I go to my library, I go to bolts, number 10, FHCS is flathead cap screw. And let's see, there, 1.375. Select one, get another. All right, now I'm going to quick mate these in by clicking the round face, holding Control and clicking the cylindrical face in here. And the option we're going to use is called concentric. That means concentric means if you have 2 circles, that they have the same center. And that basically means that the circles are inside of each other. And I'm going to quick make the face over. Super easy. Quick mate. Nice, and that gets me the bolts to hold the little block together. We make sure that we have the thin plate on the outside, the thick plate on the inside, and I'll have another video where I explain all the little details I'm skipping over in depth. So we're going to go back to our library, go to bearings. I'm going to look for a Thunder Hex flanged bearing. It's one of the last ones. Thunder Hex flanged 4006 is the part number. Perfect. Okay, so that one goes over there. Is that the only one? SolidWorks does this fun thing where it likes to just not do what you ask it to. I don't know where the other bearing is. How fun. So in a scenario like this where it says I have 2 bearings in the feature tree, but I can't find one of them. One way thing I can do, I can go to zoom to selection. So it thinks it's inside of this other bearing. That's what I thought. What I did is SolidWorks decided to put the 2 bearings together and automate them, which sometimes is useful, but most of the time it's not what you want. So if you click on it and you click over to this view mates, you can see it's mated to something, which is the other bearing. So what I'm going to do, I'm going to select the mate and delete, select the mate and delete. And then if I click and drag, suddenly the bearing comes out of the other bearing. So I'm going to use my right mouse to move it over. I'm going to quick mate this one to the front. I'll drag it out, and then this one concentrically there as well, and I'll drag that a little bit out. Now the bearing blocks have this little nub inside for the flange of the bearing. The flange is the little part that sticks out. So we're just going to quick mate those together on both sides. Oops, daisy. Easy little quick mate right there. And as for wheels, we're just going to be using the West Coast Products aluminum wheels. So let's go down to wheels in our design library. And let's see. Here we go. Normally these wheels are intended to have tread on them. For the quick purposes of this explanation, we will skip the tread. So I'm going to mate these together. All I did is I made it concentric, and then I made the little face coincident over there. Now, before I do too much more, I'm just going to add everything to my mirrors. Sorry, I did a little quick. I'm just going to go back to my mirrors and edit the feature and go start with the first one. I'm going to mirror over the bearing block, the wheel, the bolts, the bearings. And that's just going to go from left side to the right side. And I'll do the exact same thing with mirror 2. You have to mirror things in the order of the mirror features. So let's see. Whoops daisy. Looks like everything. Yep. And then I'm going to go to this side. Select that, mirror it over. And you can see I'm starting to slowly get some semblance of the drivetrain together. Now if I go up to the gearboxes section, let's see. See if I go to WCPSS, WCD, it's me the West Coast Drive or West Coast Products single speed West Coast Drive edition. So if you can see, we have a bearing block, some stuff sticking out. Anywho, what we'll do is we will get these flathead bolt. We'll make it concentric with the hole there. We'll get the other one on the other side and make it concentric with the hole there. And you know you've done your spacing right if it magically works. We'll get this place, or that face, make it coincident there. And that's more or less it for that side. I'll drag out another one of these wheels. The way I'm going to do that, I'm going to hold Control, click on the wheel, and just drag it. Let's see. I'm going to get this concentric with some kind of round surface that's centered there. So I'm just going to do the center. And then I'll take this and put the edge right up against it. Now on this, the shaft is a little bit long. Normally I would edit that, but I'll save that for another video because I'm trying to just do the bare basics here. So I'm going to go back to the mirror component, the first one that's left, right. And I'm just going to select the gearbox. I'm going to select the wheel. And you can see it mirrors it over to the side. So this gearbox currently doesn't have motors. Normally you need those on a robot, but I'm going to leave them out just because I'm trying to wrap this up pretty quickly. One of the last things we need are sprockets and shafts. So we have these sprockets here. I'm just going to hold Control and drag it out. What's important with sprockets is that they are perfectly aligned. So the faces need to be perfectly aligned there. So I'll get the round part there. I will make it concentric here. There's a little bit of space in there. Normally we'd put a spacer in there, but again, time. As long as we know that there's a spacer, we should be pretty good. So let's get that face and the front face. Make sure your two faces are on the same side. The way you can tell this is when you finally do your mate, the teeth should be contacting. Oh, so the bearing did a little bork. What we're gonna do is we're gonna just drag it real quick, and it auto aligns. It's just SolidWorks doing a visual glitch. And we will mirror those over. I think SolidWorks is saying that there's an over-defined mate for some reason. I'm not sure what it's saying though. Oh, now it's gone. Okay. I think it just needed to rebuild. Sometimes when SolidWorks gets errors, what you can do is rebuild thing up here. Just builds the whole model again. Okay, last thing I'm going to do is show you how to make a shaft. I'm not going to make all the shafts because the length of this shaft is obviously longer than this one because the sprocket's spaced out further, but I'll show you real quick. In order to do shafts, what we want to do is figure out our shaft length. So this is going to be a Thunderhex shaft, and I'll have a whole different video explaining all the different types of shafts and such. In order to make the Thunderhex shaft length, I click on this face, hold control and click on this face. Down at the bottom here, it gives me, oh my gosh, really, that's convenient. It gives me a normal distance, and this is a normal distance of 2.99, a match made in heaven, if one were to say. So we're going to take that number and remember it, and I feel like it'll be a hard number for me to forget. We're going to go to make a new part. We're going to make a Thunderhex shaft real quick. How we do that is I start off by pressing Q, which gets me to my polygon tool. My polygon tool already has six sides as per the parameter by default. So I'll drag one off the origin, click on one of the little lines and make it horizontal or vertical. So now it's positioned correctly. I'm going to click the interior circle and define it as 0.5. So it's half-inch hex. Now Thunderhex is half-inch hex with a rounded exterior and a hole through the center. So the hole through the center is 0.201. You don't need to memorize these numbers. You can always ask or reference them somewhere else, but I've just memorized them after a while. The outside is the hard one to remember. It's 13.75 millimeters. So once you do that, the area in between the hex and the round is your shaft. So we can click E, and we'll move our mouse in here, and it'll select that little red highlight, and that's our Thunderhex profile. We're going to go mid-plane, so it goes out in both directions. It's just a good practice to do for the most part. And what we're going to do is we're going to get our shaft length, which is 2.99, which again was not on purpose. I'm literally just making this up. And then we're going to add 10 thousandths for each snap ring side. So we're going to have a snap ring on the side of the wheel. We're going to have a snap ring on the side of the sprocket. So plus 0.020, that's 10,000 plus 10 thousandths is 20 thousandths. So it's no more a nice clean 299, but we'll go with 3010 or 3.010. So we've extruded this out, and now to make our snap ring groove, we'll go to one side and say sketch. For a half-inch snap ring groove, the diameter is 0.468, and you can reference that off of McMaster's site because that's where we get most of our numbers. And before we extrude this, it is part of the same shaft, so we need to get this round circle, the cutout from the center, onto our sketch profile. Easy way to do that is to quite literally select the contour on the feature and go to this Convert Entities tab. This Convert Entities feature will just take anything that you click that's already in a feature and convert it to a sketch. So now when I click E to extrude, it's going to extrude with that hole in there. We don't extrude it the whole 3 inches like we did earlier. For a snap ring groove for half-inch, we do 40 thousandths, 0.040. And then to finish it off real quick, we're going to do the same thing, half-inch round. We're just basically going to go to the maximum diameter round that we can. So that's going to be tangent with that, because that's by definition the largest it can go. And then convert entities in the end. And I like to do 0.060. I don't know, it's a number I found works well. And that's one side, but really easily we can go to the other side, click the right plane, and we'll do our mirror entities. Our mirror feature. Select both of those features. It mirrors over quite nicely. And for finishing touches to make it nice, we're going to add a 30 thousandths chamfer right over to those little edges right there. Chamfer is a 45-degree angle. It helps when you're sliding something onto the shaft. Makes it align better. Personally, I think it just looks nice. And that's good for us. We're going to save this part as just the next part number in the sequence. So we just click on the old one and delete and put the new number in. Now the way I'm going to put the shaft in, go to insert components, put the new one in. Now the round part of the Thunderhex is still concentric with the center, so I'm just going to click that and find some round part here, make those concentric. I'm a stickler for this. You don't have to do this, but I like to line up the hexes, or actually the flats of the hexes. So I click one, whoops, it is not Windows key. Click one, hold control, click the other, and it's not coincident. You want to do parallel. It's a very interesting thing to take note of, but it's not coincident. Use parallel. And then we'll take this out, and we'll do the nice width mate. Before I knew about the width mate, I would use the distance mate and figure it out by hand, and then always update it. So I'm just going to width between the inside of the wheel and the sprocket. It has that little bit on the outside for just for tolerancing, and You can see we're perfectly aligned with the hex on the inside. The hex on here needs to be aligned. So I'll just do that nice and quick. And there we go. To show that that's working, I can move the wheel. The sprocket moves with it. That's not at all a necessary detail. Like, it provides me no competitive advantage. I just think it's fun. I'll mirror that over, and we have shaft going through. This is a complete set right here. No shafts up top, but I'm sure you could do those on your own. Now, normally we'll create gussets, which are little plates to hold together the different tubes. But again, I'm trying to finish this up pretty much now, so we'll just save gussets and belly pan and other detail work like cams for later. But if you can do this in however long this took, which is much longer than I intended, you can get together what is mostly a West Coast drive. So try it out yourself. Ask me if you have any questions. And as always, keep designing.